continue talking about arithmetic sequences. We're going to develop a formula for finding a particular term of a sequence. So let's say, for instance, I had the sequence 3, 6, 9, 12, and so on. We know that that's arithmetic because we add 3 each time to get the next term. So I know that the common difference, we'd find that again by taking a term, pick 9, and subtract the term in front of it. So we know that the common difference is 3. Let's say, for instance, we wanted to find the 38th term of this sequence. So we want to find what number comes. If I went out here, remember this is a sub 1, a sub 2, a sub 3, a sub 4. I'd want to go out until I found the 38th term that appears on that. I could start listing these out and count until I got to the 38th one, but that doesn't sound like fun to me. So we're going to develop a formula for how to find that term without having to write them all the way out. And we do that just by looking at each of the terms. If we look at a sub 2, what we did was we added 3 to find that term, to the first term. So we did 3 plus 1 times 3. If we look at the third term, what we did is we started with the first term, I added 3 here, and then I added 3 again to get the third term. So what I did was I found that a sub 3, 9, is equal to the first term plus 2 times 3. I added 3 twice to go from 3 to 9. If I look at the fourth term, 12, what I did was I added 3 once, twice, 3 times. And if you look to the next term, the next one would be 15. That's going to equal 3 plus, I would have added 3 4 times. What's interesting is look at this number, the subscript of the term that we're finding, and what this number is here. 3 and 2, 4 and 3, 5 and 4. Notice that this number is just one less than whatever term we're trying to find. So if I were trying to find some unknown term, the nth term, a sub n then would be the first term plus 1 less than n, which is n minus 1, times d, the common difference, which in this case was 3. So drawing from just a general case where this was a sub 1 and this was d, I could have what's called an explicit formula to find the nth term. A sub n is equal to a sub 1 plus n minus 1 times d. So if I wanted to go back up here and I wanted to find the 38th term of this, all I would need to know is what's a sub 1, what's n, and what's d. And so this is n is which term I'm trying to find. I know my common difference is 3, and I know my first term is 3. So to use that formula, again, I'll write it right up here again. A sub n, we don't know what that is, a sub 38. It's the first term plus 38 minus 1 times the common difference, which is 3. So a sub 38 is 3 plus 37 times 3. A sub 38 is 3 plus 37 times 3 is 111. A sub 38 then would equal 114. And if you wanted to verify, you could take this out and find out that 114 would be the 38th number on that list. We can do that with another example. So here's our explicit formula that we want to be able to use. So one more example, if I had the sequence 53, 47, 41, and so on, and I wanted to find the 18th term of it. So first I'd have to find the common difference. So what I do is I pick a term, doesn't matter which one, and subtract the term right before it. And in this case, I'd get -6. N is going to be 18, and a sub 1 is 53. So my nth term, the 18th term then, would be, my dog had to come and visit me right now, the first term plus 18 minus 1 times the common difference, which is -6. And if you work that out, the answer comes out to be -49. The second topic we're going to talk about then is finding what are called arithmetic means. And what that is just the missing terms in between terms of a sequence. So let's say I wanted to find the 4 arithmetic means of the sequence 16, 'So I wanted to find those missing numbers in there. So what I want to do is develop a formula like this for this sequence. We just don't know what the common difference is. And so we know what a sub 1 is. We know how many terms we have, so we know n, and we know what a sub n is. So again, the formula is a1 plus n minus 1 times d. This is what we need to find, because then we can just add it each time to find those missing numbers. So I know that the sixth term, 1, 2, 3, 4, 5, 6, is 91. The first term is 16. I know that n is 6, so 6 minus 1 times d. And if you solve this out, you minus 16, you get 75 is equal to 5d, so d equals 15. So then all I would do is I would add 15 here, and I get 31. I'd add 15 and I'd get 46. I'd add 15 and I'd get 61. I'd add 15, I get 76. And then if I add 15, I get 91. Those are the topics on your assignment for today.